So welcome to BioCurious, and to those folks I recognize, welcome back to BioCurious. If you've not been here before, we are basically a hackerspace for biotech. So what we do is we have memberships where people can come and go and work on projects in the lab. Excuse me. We also do lectures. We do a combination of hands-on classes and lecture, so that you can hear about something and then go into the lab and actually do it. So couple of quick announcements. If we need to evacuate the building for any reason, there are 2 exits. You can go this way, or you can go this way. This is where I play flight attendant.
That's right there.
Yeah. For us, safety is really important because we are a lab. There's real science going on just on the other side of this blue line. So for us, there's a blue line on the floor here, and that designates the lab area. You are welcome to have a tour of the lab if you want one after the talk. Just see me, see Raymond, or see anybody else who is a member of Space. Okay? If you like what we're doing here and you want to be a member or contribute, talk to me. I've got 14 dozen ways you can get more involved. But without further ado, I would like to introduce my other co-founder, Raymond, who's going to introduce Seth, our speaker.
And I'm not going to talk long because you guys want to hear Seth, and that's good. One of the pleasures that I had whenever I moved to Silicon Valley was I got to see all these great people who were working on great things and were very accessible. I mean, accessible because you could go to talks at night, but also like you could run into them at the grocery store. And I've heard Seth talk probably 4 times, and every time it's just been an absolute pleasure. And everybody says don't oversell your speaker before you introduce him, but it's hard to not do that with Seth. So Seth is the senior astronomer at the Seti Institute. He's got a degree in physics from Princeton and astronomy from Caltech, and is one of those rare science communicators who's actually got, as literally dozens, I think 60 technical papers and about that many non-technical, communication pieces for non-scientists, and so really talks about great stuff in the field. And that's the kind of, hit from the hip introduction I give. Please welcome Seth.
Thank you very much, Raymond. Never a good idea to applaud before the talk. The buyer's regret. Okay. It's nice to be here at BioCurious, although I find it somewhat curious, actually, because I don't know how many of you are familiar with something called the Fermi Paradox, which is a simple argument that was put forward by this guy Enrico Fermi back in 1950, suggesting that maybe the aliens aren't out there because we don't see them here, right? He wondered where everybody was. There's been plenty of time for somebody to colonize the galaxy, whether it's the Klingons or who knows what. And since you don't see any evidence of aliens in your backyard, or if you do, please see me later. I mean, what he was saying is, where is everybody? Right? And one of the more intriguing explications for the Fermi Paradox, written up in a paper by some guy at some university in South Carolina just a couple of months ago that I happened to read. Actually, I guess I was the referee. I don't know what it was. But in any case, and he said the reason you don't see the aliens is because there aren't any aliens, and the reason there aren't any aliens is because of biohacking. He said that what happens is, at the moment that you invent radio so that you can go on the air and we might be able to find you, you invent biohackers, and then they immediately, the bad apples there, develop some pathogen that wipes out the entire species. I don't know if you buy into that, but I thought it was kind of an intriguing idea. Okay, I'm told you got to be out of here by 11:30, so what I'm going to do is just talk a little bit, about SETI, which is not all we do at the Seti Institute. The Seti Institute, SETI, it's almost my name. Okay, that's Search for Extraterrestrial Intelligence. I think you all know that. It's located about 3 miles up Central Expressway. It's not far from here. Okay, Mountain View. I'm part of the SETI group, so we're looking for the kind of aliens that can hold up their side of the conversation. But I have to say that most of the people that work at that institute are what are called astrobiologists. So they're interested in life that might take a microscope to see. You're used to that. But, so we're looking for the ones that are a little brainier. And that's mostly what I'll talk about. Even though the chances are that if we find life in the next 20 years, and I think we might, it's very likely going to be life that's not too smart, but at least it's biology. And that would be interesting because it would prove you are not a miracle. I know you like to think you're a miracle. It's because your mom's told you that ever since you were a kid. Okay, Seti got started back in 1960. This is a photo I made 2 years ago, this particular antenna, but this antenna has existed since 1959. It's in lovely, glamorous West Virginia, and it was used by this guy, Frank Drake. He took this antenna 85 feet in diameter. He pointed it at a couple of nearby stars, hoping to eavesdrop on ET. How many of you have seen Contact? Okay. So you know what the deal is. You understand the idea. I mean, that idea, that's not even a new idea. Tesla thought he could communicate with the Martians this way. The trouble was that Tesla was working at very low frequencies, and he really couldn't have communicated with the Martians, even aside from the fact there are probably no Martians building transmitters. But the idea is old. The idea is old. Anyhow, he did this. He listened for 2 weeks, and he didn't hear anything, which is not actually true, because he did hear something, but it turned out to be the U.S. Air Force, and that it didn't count as extraterrestrial intelligence. Okay, but the idea is very sensible, because you can convince yourself it's a one-line calculation, right? Take the most powerful transmitter on the Earth, some radar transmitter, right? Put it over here, and then put the most sensitive receiver over here, and then separate them to the distance at which you can just barely hear the transmitter with the receiver. What is that distance? And it's light years, many light years. So this should work. You can send bits across the galaxy much more easily than you can send the baryons. Send yourself. Send, Mr. Spock. Okay, now let me just say something about SETI in general, because there was a comment, in fact it was down at Caltech by, what's his name? Michael Crichton, the novelist. At one point he was talking about SETI and he said, it's a religion, right? Which I thought was an interesting comment, because if it really were a religion, we'd have a lot more money, right? But I think his point was that it wasn't sort of conventional science, right? What you learned in middle school, right? You have a hypothesis. Remember all this stuff? You have a hypothesis, and then you design an experiment to try and falsify the hypothesis. Because if you can do that, then at least you can get rid of that hypothesis. Okay. Well, that's not what SETI is, because you can't falsify it. The hypothesis is ET is out there, but there's no way to prove that ET isn't out there. You can't do that. There's a zillion ways you can miss finding ET. You can think of many, I'm sure. So all you can do is hope to find something. So it's like exploration. It's like exploration. It was like, in 1500 you could have sat around in the bars of Europe discussing whether there was a big continent at the bottom of the Earth. Right? People did that, actually. They had all sorts of nifty arguments about it. But you could have all the beers you want, but in the end you had to do an experiment. Just send some ships down there. So that's what they did. Okay. Now, the antennas we're using these days to try and eavesdrop on ET are these. This is the Allen Telescope Array. That's not Woody Allen, by the way. That's Paul Allen, co-founder of Microsoft. He put up the money for the first 42 of these antennas. They're not so big, 6 meters, 20 feet across. So they would fit in your backyard, or they'd probably annoy the neighbors. And they cover a very wide frequency range. There are only a couple of them here. But now, what are we looking for with these things? People always say, okay, so if you're using these antennas trying to eavesdrop on signals, are you looking for the value of pi? Or maybe, if you're a Dan Brown fan, maybe the Fibonacci series or something like that. Well, we don't look for anything like that. You're looking for intelligence in the signal. You've got these complicated algorithms looking for patterns in the signal. No, none of that. Don't want to disappoint you, but it's none of that. All we do is we look for a signal that's narrow band. It's at one spot on the radio dial, one part of the spectrum. And that's what this is. This is actually just a little bit of the radio dial. I'm told every time you show a graph, you lose 10% of the audience. 12%. Okay, so here you have just a little bit of the radio dial. So the low frequency, high frequency, and this is just time. You see all the noise in the receiver here, but even with your eye, you can see that signal. Now that signal, we picked this up with our equipment down in Puerto Rico. We're using a big antenna there. That signal is the Pioneer 10 spacecraft. You may remember that. It's the one with the nudie cutie plaque on it. Okay. But at the time that this detection was made, it was 3 times farther than Pluto. Right? It was billions of miles away, billions and billions of miles away, and the transmitter was about the power of a bicycle lamp. It was a couple of watts. Okay. So here's a transmitter, a couple of watts, 3 times as far as Pluto. You can just see it with your eye. No big deal. But you notice it's narrow band. It's at this part of the radio spectrum. It's not over here. Nature makes a lot of radio noise. I used to study it back when I did astronomy. But it's all over the dial. Doesn't matter where you tune, you'll find it. It's like lightning. Right? Lightning produces light. You see it, it's white, every color. But it also produces radio static. If you have your radio on, you hear this crackle. And it doesn't matter where you're tuned, you'll hear that crack. Whereas if you're tuning in your favorite country and western station, which is I know what you listen to. If you're tuning in your favorite country and western station, it's at one spot on the dial, right? You hear just, and there it is. Okay. Same deal. So that's what we look for. The question of what are they saying, that's something you would go and try and find later. It's much easier to first find the signal, find the on-the-air sign, right? And then go back later and build something that's 1,000 times bigger, and you might be able to get the bits. Okay. So. Here are just a couple of numbers for those who care about numbers. This is the big antenna down in Puerto Rico. Anybody seen this? Anybody been there? No. Go see it. Because they may truck it away. Let me go away. National Science Foundation has told these guys, you've got to find half your own money now. Anyhow, but it's very impressive. It's 1,000 feet across. It holds, I reckon it holds 4 billion scoops of Baskin Robbins. Not a good idea in the tropics. But this is kind of the best sensitivity you can get with our system. That's a very small number. 10 to the minus 25 watts per square meter. Okay. And that's what you can detect easily. If you get nothing else out of this talk, maybe you'll get this. Radio techniques are very, very sensitive. In fact, all the radiation ever collected by this thing, studying galaxies, quasars, pulsars, all that stuff, amounts to the amount of energy of one ant lifting one leg after 40 years of doing this. So it's very, very sensitive. And what that means is if you postulate that they're aliens, 100 light years from downtown Sunnyvale, and they have an antenna the same size as this, you would hear them if their transmitter power was 100 kilowatts or more. That's not much. There are television stations up in San Francisco probably that are around 100 kilowatts, FM stations, very close to that or maybe more. So that's not a lot. 100 years after Marconi, we can do this already. Okay, have we found them? No. I get this question all the time at cocktail parties, not that I go to any, but people come up, well, have you heard the aliens? I find that a very interesting question, because if we had, you would have heard about it. I wouldn't even be here. I'd be in Stockholm, right, collecting a prize, having dinner with the king, whatever, something. And so we haven't. But the second question they ask is, so are you close? Which is even nuttier question. I mean, this is a one-bit experiment, right? You don't know anything until you find it. Right? You're never close. It's like asking, are you pregnant? No. Are you close? What does it mean? I don't know what it means. Maybe Saturday night you're closer. Okay, so far we haven't found them. We haven't. But I think we might find them pretty soon. Now, part of the reason we haven't found them is not because they're not out there. I mean, there are books out there called, the Eerie Silence and stuff like that. Paul Davies wrote a book with that title. But he knows very well that there's no eerie silence. It's only that we've only looked at a few thousand stars. That's a very small number in a galaxy that has a couple of 100 billion stars. Right? That's like looking for elephants in Africa and giving up after looking at one city block of Africa. Well, no pachyderms here. Okay, that's too soon. Right? So it doesn't mean anything. It doesn't mean anything. But here's the good news. We now know that there are a lot of planets out there. That's something we didn't know. Even recently we didn't know that. Here's a bit of the Milky Way. There are a couple of 100 billion stars. The question has been for a long time, what fraction of those stars have planets? When I was a kid, just before the outbreak of the Crimean War, I used to go to the Hayden Planetarium in New York, actually, and they would tell you, our solar system was made by a close encounter with another star. This very complicated mechanism, if true, would have meant that ours is the only solar system in the entire galaxy. All that stellar goodness, and this is the only place where there are any planets. Right? That's what that would have meant. But that's not true. It now turns out, and this is a result of the last 18 months, that something like 70%, 80% of all stars have planets. 70% for an astronomer is the same as all. Have to quibble, right? In astronomy, pi is equal to 1. Okay, so most of these guys have planets, and they probably don't just have one planet. It's sort of like litters of kittens. You don't get one, you get a bunch, right? So, that means that's kind of the number of planets, and maybe most of them are worthless, like Neptune. But it strains credulity to think that they're all worthless. Okay? And in fact, finding out what fraction of them are not worthless is the job of the Kepler Space Telescope, which is run out of NASA Ames, right nearby. NASA Ames. Go to Singularity University. The Kepler Space Telescope, which has certain problems now, but it has a very simple mission, should it choose to accept it. Its mission is to simply figure out what fraction of stars have an Earth-sized planet at the right distance from the star where you could have liquid water on the surface, not too hot, not too cold. Now, the answer to that, so what's the answer to that? What fraction of stars do? Is it 1 in a million? Is it 1 in 3? What is it? And the answer to that question is, we don't know the answer to that question. But it will find the answer to the question, even though Kepler has got problems. Here's a hint. I think this is a pretty good hint. This is just a graphic made down in Puerto Rico of planets that have been found in the last 15 years that are thought to be more or less the size of the Earth and in the so-called habitable zone. In other words, not too close, not too far, so you could have oceans. How many of these guys are there? Well, like 9 of them. How many planets have we found and confirmed around other stars? About 800, 900. So that's saying, 1% of all planets might have, 1% of all stars might have a planet that's habitable. Now that's an interesting number because it's not 1 in a billion, right? 1 in 100, that would be great. Given that there are a trillion planets in the galaxy, if 1 in 100 of them could support life, then you've got 10 billion planets where nature is hacking life. Okay, so that's good news. And here's another, I would like to show this slide. This is a picture I made in part of Australia you've probably never been to, never would want to go, unless you like, flies and cows. But this, in the northwest corner of Australia, you have these Pilbara hills here. And they have the best preserved sedimentary rock in the world, as it turns out. It's just a geologic anomaly, just like most of Australia is an anomaly, particularly the nightlife. But so these are very old rock, okay? I mean, we know how old this rock is, radioactive dating. It's 3.5 billion years old, plus or minus a day or two. So, that's known very accurately. But what you see in the rock, we see these guys here, you see these things that look like fossilized cauliflowers. They are not cauliflowers, they are fossilized stromatolites. Probably you guys all know what a stromatolite is. They're just, big mounds made by bacteria. Okay? So here you go, 3.5 billion years ago, there obviously was life all over the planet because you just look in some rock there and you find this stuff. That's interesting, because it seems like life got started right away. It didn't take much time. This was an easy experiment. Nature didn't spend billions of years getting life started. It just happened right away. And that's suggestive, Okay, here's the Allen Telescope Array. What are we doing with it now as you sit through this soporific presentation? We're looking at a couple things, might as well tell you what they are. One, we're just looking in the direction where Kepler has found possible planets. It's got 3,000 of these at least now. Okay, so here are some of them. So we know that those are at least worlds that have planets, so we point the telescope there. The other place we're looking at is Action Central, the Galactic Center. I don't know how many of you have been to the Galactic Center. It's about 28,000 light years away. But it's where all the action is, so if you're interested in the action, giant black hole, all sorts of supernovae. It's got all sorts of nifty stuff. You can't see it with your eyes because there's all this dust in the way, but if you have an infrared telescope, you can make nifty pictures like this. So there it is. Now, if you think about it, that's the one special place in the galaxy that everybody will know about. Right? I was a kid watching Star Trek, right? They would beam, Kirk would beam Scotty down to, not Scotty, he'd just beam Spock down to some godforsaken planet. And they never say, by the way, this is where you have to go. He just beamed him down. But there are at least two places you could always find Spock, the North Pole and the South Pole. Everybody can figure out where those two things are. Well, in the galaxy, you don't have a North Pole or South Pole, but you have the center. Now, this galaxy's been around for maybe close to 13 billion years. Right? So, 2/3 of all the stars out there are older than the sun. 2/3 of the star are billions of years older than the sun. So, there could be some really advanced guys there. I know you like to think you're advanced, but I mean, these guys could be really advanced. And maybe they've put a big beacon down there because they know everybody will look there, which gives you, the galactic weather report, or maybe it's a GPS system for the galaxy, or, I don't know, web access, something. So we're looking there. That's what it looks like in the infrared. This is what it looks like in the radio, but never mind what it looks like. Here's my favorite, this is my favorite target of choice these days, red dwarfs. Red dwarfs. Anybody from Britain will know there was a TV series called Red Dwarf. This is the nearest red dwarf to us, Proxima Centauri, which actually happens to be the nearest star to us. You can't see with your eye, you need a pair of binoculars. Anyhow, these guys are small. So there's the sun, that's a red dwarf, they're tiny guys. So they don't have much fuel. But on the other hand, they're like VW Beetles. They have much fuel, but they don't have much of an engine either. So these guys last for a long time. the sun's going to burn out in another 4 billion years. I figure most of you have made plans for that. Okay, so that means that the sun's lifetime for life is, given that things are going to start going funny in another billion years, it's like 6 billion years, something like 7 billion years. So in a way, you just made it. If it had taken another couple of billion years to evolve you wouldn't have evolved. Right. But, so we just made it. That's lucky. But red dwarfs, they go for 100 billion years and more. They never age. Right? I say it's like Frank Drake. He never ages either. I think about it. But okay. All right. So these red dwarfs. So that makes them kind of interesting. They're the runts of the litter. They're small. They're not very bright, like my brother. The other thing is that they have very small, what are called habitable zones. Okay, habitable zone. Here's a habitable zone for the sun. I know you don't care about all this astronomy. Okay, here's the sun, and if you're a planet that's really close to the sun, it's too hot. And out here, it's too cold. But if you're in the green area, well, okay, now you might have the Pacific Ocean, something like that. Okay, for hotter stars, that's bigger. That's just geometry. Bigger donuts have the bigger width. And cooler stars, the habitable zones are very small. So people always threw these guys away, these little red dwarf guys. Because, what are the chances you're ever going to find any planets there? It's too small. But that's wrong. That's wrong. Some results from some guys at Harvard here recently showed that 15% of all these guys have a planet in that space. 1 in 6. That's a lot. But there was a problem with those guys, because if you have a planet that's that close to its star, something awful happens. They become tidally locked. Sounds like a term from golf. Tidally locked just means that one side, very quickly, is facing the sun. Just the way the moon is tidally locked to the Earth. You may have noticed this. You only see the same side of the moon all the time. That's not an accident. That was set up right away. Right? It's just the torques on it. This is 17th century physics or something. I mean, that happened very quickly. But it would happen to any planet that was really close to a red dwarf star. And so 5 years ago, 10 years ago, if you'd gone to NASA and you said, what do you think? I mean, could you have planets that are really close to a red dwarf that would be habitable? And they'd say, no! And here's why. Because the side that's facing the sun is going to be 50 degrees centigrade. It's going to be boiling hot. And the other side is going to be freezing cold. Because it's always sunny here. And it's like Philadelphia. It's always sunny here. And it's always freezing there. Okay? And so it's so cold on the backside that the atmosphere, if there is any atmosphere, it's just going to freeze out and drop onto the ground like snow. Right? And that'll ruin your whole day, because now there's no air. Well, this turned out to be naive. Because it turns out that if you actually had an atmosphere on a planet like this, you'd immediately set up winds. Right? The winds would carry some of that heat from the front to the back. So, in fact, that would even out the temperatures of diminished models of this. So here's an artist's rendition of what it might really be like. Too hot over here, too cold over there, but there's this belt of life, right? It's like suburbia. So the belt of life, and that might be great. All right, so you ought to consider these stars. So I think we ought to look at more of them. To begin with, 3/4 of all stars are red dwarfs, and that means that there's so many more of them that if you look at 1,000, on average they're half the distance of any other kind of star. So that means the signals would be stronger. That's a great thing. 1 in 6 have maybe an Earth-like world, and they last for billions of years. And if you're looking for intelligent life, an older planet is better. This is one of the few circumstances where older is actually better. Because if it's older, it's had more time to evolve beyond, microbes and all that stuff to something like you. So I think we ought to look there. All right, when are we going to find them? I have to say, when I first came to the Seti Institute, I go to, I don't know, whatever, public events, and the public would always ask the astronomers, when are you going to find them? And I figured, these people were going to say, well, we don't know. I mean, we don't just... No, that's not what they said at all. They always gave a number. They said, well, it's going to be years, right? And I listened to the answers, and the answers correlated very well with the number of years until they were going to retire. Sure. So I figured there wasn't any information in those answers, but here's maybe a better answer. To begin with, people think, okay, you guys are sitting around with earphones trying to hear ET, right, like Jody? No, of course not. We got a bunch of computers doing all this, because you're monitoring, 50 million channels at once. Right, so, of course, computers are. But the point is that the computers are getting faster thanks to this Silicon Valley, okay? And in fact, this is just some metric of how fast we're doing our search. These dots, here's Frank's first search. Now, for the three of you who are still conscious, you may notice this is a semi-log plot. Right? This is going up exponentially. An overworked word, particularly in the media. Everybody, well, it's going up exponentially. Well, it really is exponential. It's Moore's law. So, in fact, the speed of the searches is doubling, like every 2 years. So that means whatever you're doing today, probably dwarfs everything you did before. And that will continue to be the case. So you're looking for a needle in a haystack, but, you keep replacing the spoon with a bigger spoon. And so the only question is when you're going to hit a needle, and that only depends on, how big the haystack is. How many needles are out there, and that's what this plot is. So here you see, this just shows how far out in the haystack we're looking, but this was Carl Sagan's guess as to how many societies are out there broadcasting signals that are going through your bodies as you suffer through this. He figured like 1 million. Well, if he's right, we're going to find ET pretty soon. Isaac Asimov figured 670,000. You can do this at 2 decimal places. And, then it'll take a little longer, 2020, 23. Frank Drake himself says 10,000. That's a very conservative estimate in this pantheon of guesses. But even if Frank's conservative estimate is correct, we'll still find ET before you guys hit middle age, right? Except for those who've already had it. All right. Well, that sounds good. And that's why I bet everybody at a couple of Starbucks will find ET by 2025. However, if you ask Frank, and I have asked Frank, where'd you get this number? 10,000, where'd you get it? And he said, well, coming over the hill on Highway 17, and it just seemed like a good number. Okay, so it doesn't necessarily mean anything. It's just Frank is a very smart guy. So if he says it, sounds good to me. So what I'm really trying to tell you is that if there's anything to this, and maybe you don't think there is, but if there's anything to this idea, it's going to work soon rather than later. Okay. All right. Well, finally, so there's my bet. The usual assumptions. Now, what happens? You like that say, so what if you find it? What happens then? Are you going to tell us? All right, this is the Hollywood version. Anybody see this movie? Anybody know what this movie is? Sign of an ill-spent youth. Okay, there's Chuck E. Sheen, who's really a nice guy. In The Arrival. The Arrival had the unfortunate luck to come out, like 2 weeks before Independence Day. So nobody went to see this, but yeah. So there's Charlie Sheen and his lab assistant down in LA. They set up this antenna, and they're sitting around looking bored about 5 seconds before this shot, and now suddenly they're all excited because there's a spike on the oscilloscope. Okay, so that's what Hollywood figures it's going to be like. This is the real field. This is Mountain View, California, 1997, in the basement of the Seti Institute, and we thought we'd found something. For 16 hours, we thought, this is it. And I made this photo at 3:30 in the morning. I was so nervous I couldn't sit down. Making pictures. Right? And I kept waiting for the men in black to show up. They didn't. I kept waiting for the mayor of Mountain View to call up. He didn't. I kept waiting for the guys, the feds, to call up. They didn't. The military, they didn't. Nobody called. Nobody was interested. Right? Nobody was interested. It was kind of remarkable, actually. So eventually the star set, and we had to wait to see whether it was going to come back and so forth and so on. So I went back up to my desk, and I was, half asleep. I'd been up all night, and the phone finally rang. And it was the New York Times, one of the science writers there, Bill Broad. He said, okay, Seth, what about that signal you're following? I'm not going to lie to the New York Times. Yeah, we're following the signal. I said, but we're tracking it down. Can I call you back in 3 hours? He said, okay. So I did. And it turned out it was a satellite that was just, the signal of it was just bouncing around the steelwork just the right way. So, okay, it was a false alarm, so the Times didn't write it. But this is what it'd really be like. Now, is there a document telling us what to do then? Yes, there is. Here it is. It's really boring. In fact, I chaired this international committee for 10 years. We're trying to rewrite this to make it slightly less boring. But it says something very simple. It says, well, first check the signal. Well, duh. 2, tell everybody. Well, you don't need to tell everybody. They learn about it anyhow, right? I mean, if you pick up a signal, everybody's typing emails to their boyfriends or girlfriends. Well, Marge, probably you shouldn't say anything, but we got this signal here. And then immediately her brother puts it on his blog and whatever. So, it gets out there right away. The government has no interest, apparently. So part 2 says, tell everybody. The third thing is the only interesting thing. And it says, don't send a reply without international consultation. Whatever that is. And it doesn't specify what international consultation is. I always suggest, is that the Swedish chess team? What is that? Is that international consultation? And it's unspecified. Okay. Now, why is that in there? That's in there for historical reasons. Many of you don't remember the Cold War, but for a long time, The only people who were really doing this kind of experiment were the Soviets and us. Okay? And there was some concern that if the Soviets got in touch with ET first, they might try and, corner the market on the Klingons or who knows what. And, get all the So they said, all right, wait, don't you broadcast back. Hi, we're the Soviets. Look, we got all these used cars we'd like to sell you. So that's what it was. Okay, that's still in there. But it doesn't matter. I'm going to get to that. It doesn't matter. This is what the public expects. This would be great if the Men in Black show, because if the government can afford to pay these guys salary, then maybe they can afford to pay something for our efforts. But they can't. It's goofy. It's goofy. And by the way, the reason I say it's goofy is because the public assumes that if we were to announce we'd found ET, the populace would go nuts. Right? I mean, is that what would happen? If you read in the paper tomorrow, if you open up your browser tomorrow and you read, okay, scientists find signal coming from 827 light years away, or whatever. And you say, well, that's it. That's it, Bob. I'm not going to work today, man. I'm going to riot in the streets. Now, I don't know how many of you are planning to do that. If you are, I'd like to talk to you further. But we know that's not going to happen. This isn't just supposition on my part about the better nature of human beings. I mean, we've done the experiment. We did the experiment 100 years ago. Here's Percival Lowell, rather an accomplished astronomer, and he mapped all these canals on Mars. And he wrote about it. He was a good writer. He was a good speaker, right? Yeah, Percy Lowell. And so he was saying, well, there's this vast hydraulic society just 35 million miles from Sunnyvale, and it was in all the papers and everything, and nobody cared. They cared a little bit more when, Orson Welles made a radio play about it. Some of them cared more. But nobody cared. Saying, oh, that's interesting. By the way, I need to get a shoe shine. Right? Nobody cared. People don't riot in the streets about this stuff. They just find it interesting. Now, but what about religious belief? Well, that might be a different thing. Here you see Galileo having trouble with the church because he was saying that, look, maybe Earth isn't so central after all. I mean, Galileo made the mistake of turning his 2-bit telescope in the direction of Jupiter, right, where he immediately saw 4 moons. Okay. Tried to name them after the king, hoping to forestall trouble, but in the end they didn't allow that. Anyhow, okay. But the point was, well, so what? Okay, Jupiter has 4 moons. I think Jupiter has at least 65 moons that we know about. 4 moons. But what he was saying was, look, Earth is, we think Earth is special, and God has given us this moon to keep you happy, right? Or something like that. Because you are worthy of that. Is it time for third period? Okay. All right. He said, but wait a minute, that whole idea becomes a little suspect when you see that this other planet has 4 moons. Those Jovians must be much more important than we Earthlings. So the church didn't like that idea. Anyhow, okay, I mean, these guys were not so unsophisticated as to think that Galileo was just making this stuff up. Right? They knew something decent was going on here, but, there was doctrine and all that. Now, attitudes have changed. Here's brother Guy Consolmagno. You may have seen him on the Colbert Report. He works at the Vatican Observatory. And so here's his take on it. Well, the learned theologians would be fascinated and so forth. If your religion has survived millennia, if it can handle Copernicus, Galileo, even Darwin, then E.T. should prove eventually palatable. And he's a very enlightened guy, and so is the church these days. The church actually has conferences on extraterrestrial life. However, there's a dissenting view, and that comes from this guy. He's a sociologist, Bainbridge. And he says, look, this is what he says. He said, whenever scientists talk to theologians, or want to talk to theologians, they call up somebody at the Harvard school, Divinity School. Those are the wrong guys. Because that's not where the action is in religion. Where the action is in religion is in fact with the fundamentalists. And the fundamentalists will say, look, they're going to get unhappy because it's not in the Bible, and this is all a hoax. So he expects there's going to be trouble. He expects there's going to be trouble. Satan tempting you. Nobody knows. If you're looking for a PhD thesis, maybe you could study this, because nobody really knows. Then there's this. Here you see Steve. And Steve is saying, now one thing you got to be careful not to do is if you pick up a signal, don't broadcast anything back, whether or not you talk to the Swedish chess team. Because it's like shouting in the jungle. You don't know what's out there, right? I mean, you may just tell them, hey, we're the Earthlings. All right, take care of them, Zork. We don't need any competition in that part of the galaxy, just quiet. It would ruin your whole day. This would ruin your whole day. So they send their interstellar battle wagons in our direction. That's it. Because as Hawking points out, he's certainly not the first one to point this out. He wasn't the first one to say this by any means, but he was Stephen Hawking, and that gets him he said every time you have a more advanced society, more advanced culture, technically, meeting a less advanced culture, it doesn't work out so well for the less advanced. Well, that's hard to argue. That may be true. And so he's saying just don't take the chance. But we've already been sending some messages into space. I alluded to this earlier. This is the Pioneer plaque. This was sent out in the 1970s. Okay, the 1970s, and somebody at NASA, a guy by the name of Eric Burgess, but it doesn't matter. This guy realizes, hey, whoa, this is going to be the first piece of human-made hardware to be sent into deep space, right? So maybe we ought to put a builder's plate on it. So they got Carl Sagan, Frank Drake a little bit, and they built this thing. This is the size of a license plate. Actually, it's gold-plated thing. It was engraved in a bowling trophy shop up in St. Carlos. You can go up and visit the bowling trophy shop. It's still there. They got pictures of this in the window. They're very proud. Okay, so there you go. And there were two of these things. So that'll win. Now it's pretty clever. I'm sure you've all seen it. But here's the solar system: Sun, Mercury, Venus, Earth. That's where we are, right? There's the spacecraft. There's the spacecraft, so they know how big we are. This is a pulsar map. It tells them where we are in the galaxy. And then you have this. And a buddy of mine up at the University of Washington always points out, he said, Shostak. You know that upraised hand? It's a universal symbol of war. But this caused a lot of trouble for NASA. The reason being, they're new. The aliens are going to be offended by this. Never again did NASA ever put any pornography, as they told it was, on any of those things. But there have been other things. And then there's this guy. But let me just say something about this. This thing is moving into space at 7 miles a second. That's pretty fast if you're going to Milpitas, up there while you're walking. Okay, 7 miles a second. But it's not so fast if you're going to the nearest star. Even if this thing were aimed at the nearest star, at that speed it would take 100,000 years to get there. Nobody's ever going to see this. Ever. Ever. Okay. But they're broadcast. Here's Sasha Zaitsev in Russia. He's kind of an interesting guy for many reasons, but he's using this antenna and he just broadcasts every year or two. He has another project to broadcast messages to the aliens. So he's had a whole bunch of them. There's the cosmic call, like the teenage message, cosmic call again, so forth. And he incites all sorts of unhappy reaction from people like David Brin who don't like this. But he says, hey, look, there's no danger. Let's just do it. Let's do it. And even NASA did it. I don't know if you remember this. This was what, 2008. NASA just announced as well, we just sent a Beatles song to the North Star, to Polaris. Did you know that? Across the universe, en route to Polaris, 450 light years away. So, 450 years from now, minus a couple, it'll get there. And if the Polarians, if there are any, decide that they want more Beatles music, they'll, write back. And it'll take 900 years, but, finally get this response. Please repeat that. So, whatever. This is what Paul McCartney said. Send my love to the aliens. Is there any danger in this? You may think there is. And maybe we ought to take precautions. By the way, this is what I would send into space. It's just me. I wrote a little paper about this. I mean, instead of sending these stupid little diagrams, and these are little greeting cards. This is going to be one-way communication. Right? The aliens could be hundreds of light years away, maybe thousands of light years away. Anything you send to them, you better make it really interesting because you're not going to be talking back and forth. It's communication in the same way that I had it in Latin class when I was in high school. It was one-way communication from the Roman Empire. It took 2,000 years to get to me. You couldn't talk back to Julius Caesar. I mean, you could, but it wouldn't do any good. Okay, so that's why I think that if we're going to send anything, just ask Sergey Brin or somebody. We're just going to send the Google service. Turns out you can do that. I mean, technically you can do that. Send them everything. Send them everything because it's so redundant that they'll be able to figure some of it out. That's why we figured out the hieroglyphics. There's so much of it that you could eventually figure it out. That's my idea. But should we take the chance to do that? I mean, is there really a danger here? Should we just be cautionary? Well, maybe 99% of all aliens are kind of, botanists like little E.T., nice guys, except when they have a beer. And maybe only 1% of them are like that guy on the right. But, do you want to take the chance? Do you want your tombstone to read, responsible for the end of the planet? Bad news. Okay. Well, this is what we know about alien intentions, nothing. So, can't argue that point. However, let me just tell you that the bottom line here is it's too late to worry about it. Because we've already been broadcasting into space. These are, sort of the fluxes that you get from the kind of inadvertent transmissions we're sending into space, like TV. It's very weak. You couldn't pick it up, right? I mean, our best SETI experiments couldn't pick up, KGO television at a distance any more than a 20th of a light year. So those are safe, but there are some other signals that are not so weak, like the radar down in Puerto Rico. You can pick that up in 400 light years. We're already broadcasting into space. It's mostly military radars, actually. Okay. So this is the intention. The people who want to shut us up, they say, okay, what we're doing today, that's all right. Just don't make any deliberate, strong signals. And I'm here to tell you that's nonsense, because it's easy to prove to yourself that any society that could really come here and do something terrible to you, haul you out of your bedroom for these unauthorized experiments or whatever. Any society that could do that has the ability to pick up the leakage, right? Our telescope's getting bigger. This is just a plot of the biggest radio telescopes around. If they're only a couple of hundred years ahead of us, they can easily pick up our television. And we're already building bigger telescopes. The argument's even stronger. There's another way to do this. You use your own star as a gravitational lens, which is a little bit of general relativity, but you can do that. Astronomers do this trick all the time. And so if you could send a spacecraft out, 550, well, that's 55 billion miles from the sun, something that we could do. I mean, we have something that's, 1/5 that distance already. If you do that, then you can use the sun as a lens. And if you do that, you can pick up all sorts of stuff, right? You need a 1 megawatt transmitter. Yeah, you can hear that from 400 light years with our equipment. But if you use the sun as a lens, you can hear a 3-watt transmitter for 100 light years. They could listen into all sorts of stuff. And it works also in the optical, by the way. This is something else they might see. I won't go through the numbers. But they could see this, which is better known as New York City. You can see the lights from New York City from hundreds of light years away. So there's just no point worrying about all this, right? You can listen to Steve if you want, but that horse has left the barn, right? Those signals are on their way, and there's no bringing them back. All right, well, and there's an even worse aspect to all this. It's not a matter of just turning off the radars for the weekend. If you want to shut down the radars at San Jose Airport, San Francisco Airport, maybe you'd be willing to do that for the weekend as long as you're not flying. But would you want to do it forever? Because you can't just do it for the weekend. You have to do it forever. You have to hide under a rock forever. You can't build power sats in space. They leak in the back direction. You can't do any of these sort of foreseeable technologies forever. Okay, so I think that's a bad thing. Oh, this is just a last slot here. Who have you here? What's going to be on the other side of the microphone? This question you also get a lot. What will ET be like? I consult for movies occasionally, and that's the question they always ask. They ask that question, then the other question they ask is, what sort of weaponry will the aliens have? It's like asking Julius Caesar, what do you think the U.S. Air Force will have in the 21st century? Well, better spears, maybe. I don't know. So, he wouldn't know. We don't know. But this is what we assume they're going to look like. But I point out to you that this is just a projection of what we think we're going to become, right? We're losing our hair. These guys have gone all the way on that. We're losing our olfactory sense, our dentition. These guys have gone all the way on that. You've got big eyes because in the future your job description is design websites. Okay, so that's all this is. That's just you. and there was a paper that came out last week from some geneticist who tried to predict what humans were going to look like, not 1,000,000 years in the future, but 100,000 years in the future. This is what they look like. And once again, say, oh yeah, we got little big eyes. I mean, if you saw these guys, if these guys moved in next door, you'd probably talk about them for a while. But I bet you'd invite them over for dinner. Okay, eventually. All right. So, that's the usual assumption, but that's all bonkers. Because, we're just assuming that the only difference is that they've had more time to get bigger brains. Here's your brain. Your brain weighs 3 pounds. And it runs at about the power level of a fridge light. I pointed this out to my brother. I always like to wear dim bulb. You are. Okay, 25 watts. Now, your entire body runs at about 75 or 100 watts. These are numbers that you might want to keep in mind. So that essentially 1/3, 1/4 of all the calories you eat are going to keep that brain warm. Whether or not it's actually listening to this talk or merely having sexual fantasies, it's still taking 1/3 or 1/4 of all the calories. Okay? It's very expensive. That's why most critters don't buy into a big brain. It's metabolically very expensive. Okay. But maybe the aliens just have bigger brains. That's what they're like, right? Well, here's a little plot of the size of your brain for the last 3 million years. not yours personally, but you know. So here are predecessors. 3 million years ago, you had a 1 pound brain, half a kilo. And 1 million years ago, you had a 2 pound brain, and now you have a 3 pound brain. But that last step from 2 pounds to 3 pounds, you have to admit, was important. Because if you have a 2 pound brain, you're a forest ape. If you have a 3 pound brain, you can work here. Okay. So, all right. So the assumption is that, well, this curve will just keep on going up, and that's where the aliens are. They got 10 pound brains. Which I doubt, because women will go on strike if babies have 10 pound brains. Not going to happen. But never mind. It isn't going to happen for another reason, and that's this reason. You're probably familiar with these kinds of curves. This is from Hans Moravec. He's a roboticist at Carnegie Mellon. He just plots how much compute power you can buy for $1,000 ever since 1900. And it's just going up, exponentially, of course. And the point is, because his data runs out in 1997, the point is, by 2020, that laptop you buy down at Fry's will have the same compute power as a human brain. Barring World War III, this is what's going to happen. Okay. That doesn't mean it can think, but you know, the AI guys are very optimistic. And once you get it going, well, you know, it evolves very quickly. So it's a time scaling. Right? Here's Marconi, 1900. They invent practical radio, so we're on the air. 45 years later, we're building computers. Now, they're not small, but we're building computers. And maybe by the end of this century, you'll have strong AI. You have thinking machines. Go over to Stanford and ask these guys, do you think we're going to invent our successors in this century? That's that of the guy who heads up this AI lab there. And his answer was very sophisticated. He said, yes. That was it. That was the answer. Okay, well, you may not believe this. I mean, if you don't want to believe it, don't believe it. But, and maybe it isn't 2050, maybe it's 2100, maybe it's 2150, 2250. What difference does it make? It's only a few hundred years from inventing technology that puts you on the air to inventing your successor. So, I'm going to skip that. I guess I'll stop here. The point is that if we do pick up a signal, I just sort of bet you a cup of coffee that we will. Don't expect there's going to be a little soft, squishy guy behind the microphone like it always is in the movies. It isn't. It's going to be some sort of machine. Okay, I'll stop in case any of you are awake and want to ask a question or two. No questions? Yes, sir.
That was a great talk. So I am an astrobiologist, and although I would like to know your opinion about making human life multiplanetary. What's your take on that?
Making human life
Multiplanetary. Like
multiplanetary.
setting up a human habitation on Mars.
Yeah. Well, I think that we do really. I mean, obviously, I'm sort of a spacey geek, kind of spacey and space geek. So obviously, I think. I mean, I would love to go to Mars and the Moon, whatever. There's all that. But I think it's also essential because the time scales for running out of a lot of important stuff here on Earth are very short. Zinc, copper, you know, they're essential, they're cheap, but in 50 years they're going to be very, very expensive. Things like platinum are already getting expensive. You know, it's hard to come up with a replacement for some of these things, for quite a few of them actually. So if you're going to stay here forever, then it's going to get very ugly. The other thing is, if you spread out a little bit, I think that's inoculating us against self-destruction. Right? I mean, I can imagine. It's like the ants. You know, I can get rid of the ants in my kitchen, but I can't get rid of all ants because they're just, you know, they're all over the place. Okay, so it's kind of an anti-aspect. So, I mean, I can imagine it's 2150. You're sitting on Mars. You open up the browser and it says, you know, nuclear war on Earth. Everybody wiped out. Well, Luigi, there goes the export market. Yeah, but that's right. Yep, got rid of all humans. My freshman advisor in college actually was proposing that we should all be living in these rotating aluminum cans in orbit, and he'd worked out how to do all that. Wrote some books on that. Yeah. And in fact, he predicted by the 1990s there would be tens of millions of people living in orbiting space habitats. The trouble is, it's still cheaper to build condos in Arizona, but at some point you'll do this. So I'm all for it, because otherwise, bad news, I think. Yeah, but yes, sir.
Was that 97 signal? Was that the so-called wow signal?
Was that the wow signal, the 1997 signal? No, it wasn't. The wow signal was picked up at Ohio State in 1977, 20 years earlier, and it was never seen again, so probably not real. This signal was due to the SOHO satellite, the European Solar Research Center. Once again, it was the Europeans. Yeah. Solar Research Center. I used to live in Europe, so I can say that. Yeah.
Every once in a while, I'll hear somebody make kind of that civilization timescale argument and say, if, you know, you're going to have spacefaring civilizations, things are going on. At some point, we would see people re-engineering planetary systems. Why don't we look for that, or what would that look like, and what do you think about all that?
Yeah, that's good. I think that's a good point. Really advanced societies won't just leave planets alone. I mean, Mars is not very habitable, frankly. Mind you, it only has the same amount of real estate as the Earth. It doesn't do anything more than double the amount of real estate. And it only has that because there's no oceans to kind of use up on land. But Mars is very cold. There's no breathable air and no liquid water on the surface. You can fix all that. It's not easy, but in principle you can fix it. It doesn't violate physics to fix it. So you can terraform it. And maybe we should look for stuff like that. I don't know how you would look for a terraformed planet. But one thing you might look for is, some of the things have been suggested many times. Freeman Dyson, the physicist, said, well, any society that really needs a lot of energy, they'll just, put all these orbiting solar panels around their star and just beam the energy back on microwaves to their home planet and run their Wii's or whatever it is that they're using the energy for. And so those things would emit a lot of infrared, for example, and maybe you ought to look for them. And in fact, there's a guy at Berkeley who's doing that. Many people have done it. What they find is a lot of dust around stars. Maybe if they have a better experience. Yeah?
Since you're looking for kind of transmissions that come from outer space, would you be disappointed, per se, if we found that extraterrestrial life is just a bacteria? Or would you be more excited that maybe it's evolved somewhere else?
Now, would I be disappointed if we found life in space and it was just a bacterium? Well, we ran that experiment too. In 1996, I didn't show that slide, but in 1996, the biggest science news story of 1996 was this meteorite, ALH 84001. And the claim was there was, a dead Martian bacterium in it. And that was a big story. I thought it was a really big story. It ran, in font you needed, you could read that font from low-flying aircraft. On the front page of the New York Times for 3 days running. And it kind of went away. And there was only one opinion piece about the whole thing. Nobody seemed to care. And that was by this evolutionary biologist, Stephen Jay Gould. He said, bacteria on Mars. Well, essentially what he was saying was, pond scum on Mars. Look, I got pond scum in my bathtub. Why should I get excited about this? And I think that maybe he missed the point deliberately or maybe accidentally. The point is, if you find life on Mars, dead life, it doesn't matter. If you find any biology on Mars, that tells you biology is not a mirror. I mean, unless it's related to us, which is possible. But so I would get very excited about finding any life elsewhere. And maybe the best place to look for it is some of the moons of Jupiter. That's Europa. Because that won't be related to us. There's no chance.
So something like Europa, would you say?
Yeah, Europa might. Well, there are many people who think Europa should be choice number one for looking for life elsewhere. There are 7 other places in the solar system, maybe 8 now, that might have life. Look at some of them.
Those are,
Where?
what are those? 7.
Oh, what are the 7? Well, there's obviously Mars. There's at least one guy who thinks the upper atmosphere of Venus would be a great place to live if you're some sort of floating microbe. There are 3 moons of Jupiter, Europa, Ganymede, Callisto, that probably have liquid water under the surface. And there are at least 2 moons of Saturn. Titan has these lakes, liquid lakes, on the surface, and they're liquid, we know that. It's liquid natural gas, so it's a slightly different biochemistry, but it's biochemistry, it's carbon-based chemistry. And then there's Enceladus, which has reservoirs of liquid water underneath its surface. So there's more than a half dozen. And then there may be others. Triton might actually have the conditions for life. I mean, one thing you know about life on Earth, you guys know, is that life is very tough. At least if you can get it started, it can inhabit all sorts of places that don't appeal to you, but might appeal to a microbe.
So let me ask, and I don't mean this is a tough question, but it just stonkers me that you guys run with, at Seti with a tiny budget compared to a lot of things. Trade one B-2 bomber or something, and you'd be set until
Probably a century.
there you go. And to me, this is just the most provocative question you can answer, and it's not. Give us money from now until the end of the next millennium to answer the question. Why do you think it's not better funded? And I know you guys have made some forays into crowdfunding. What do you think is up with all of that?
Well, I can't answer your question entirely honestly, but I have to. It's self-censorship, but I happen to agree with everything you just said. I I think that the public actually is interested. I think if you were to grab, Mr. and Mrs. Front Porch off the streets of Terre Haute, say, what do you think, Dave? Is it worth 50 cents a year to you? Actually, the NASA program cost taxpayers 3 cents a year. That was canceled in 1993. I remember driving home and my next door neighbor was washing his car. He said, well, Seth, I guess you're out of a job, but I'm saving 3 cents this year. And he went and bought a BMW. So, I think that it's not been sold well. I think that the fundraising effort has not been adequate. Because I agree, I think that the public finds this interesting. Just look at Fox Television. A lot of it's UFOs, but people are interested in aliens. People are interested. You're hardwired to be interested in aliens, right? Like you're hardwired to be interested in dinosaurs. Everybody interested in dinosaurs. Why? They have big teeth. Fortunately, it's not much of a threat because they're extinct. But aliens are dangerous too. You're hardwired to be interested in dangerous species. Tune into Animal Planet tonight. A 4-hour special on gerbils. You'll never see that, right? They're not dangerous. So yeah, I think they would do it. That's me.
You guys ought to change that international astronomical agreement and say the highest bidder gets to find out first. And the furor over that.
Yeah, we do that routinely. In fact, there's going to be a press release about something with PayPal coming up, and they're going to say, if you give some money, we'll send you the email first. I can assure you that, in fact, if we actually find a signal, it isn't that you're sitting there and then suddenly it's there. It takes a week before you're sure. I can say, and all that time, the story's out there. So just so you know. Yes.
How did you get interested in looking for alien life in astronomy?
How did I get into looking for alien life instead of studying galaxies?
No, and like astronomy, astrology. How did you get into all this?
So how did I get into it?
Yeah,
What, you want the personal story?
Yeah,
Look,
yeah.
let me tell you. That's boring. What do you want to know? I was interested in astronomy as a kid. And there were a lot of cheesy sci-fi films when I was a kid. And I went to them all. I still do. I used to make movies. I used to make a lot of movies.
But like for someone like me, like I don't know, how did you decide to dedicate your entire life to it?
Well, that's a good question. I haven't devoted my entire life to it. I've had many careers, including being in a startup and stuff like that. So, but it is interesting. It's a big picture question. You could be changing oil down at oil changers or something like that, or you could be doing taxes for somebody or something. That's a decent living and all, but here you're at least addressing a question that everybody has some interest in, and there's something nice about it. And the fact that the technology keeps getting better, it's like the carrot keeps getting bigger in front of the dog. I don't know.
And what will you do if you find life? What will you personally do?
What would I do if you find life?
Or
go home, take a nap. Actually, I can tell you what happened that night. What I was thinking of, and I was very unhappy about the whole thing because I thought, I've got dinners planned this week, and I've got a lunch I'm supposed to have with this guy, and now this is going to ruin everything because we found something. Yeah.
So as somebody who's constantly thinking about, what if, and what if we make contact, and what if they can be like, obviously, it's pretty frustrating to be like, well, they're 900 light years away. That's not really like pick up the phone and be like, oh, there you are.
Yeah.
Typically we regarded C as a hard constant. And what, in your professional opinion, do you think of like, Alcubierre drive mathematics, where people are trying to get around it? Like, how do you? Isn't it incredibly frustrating to be like, even if we do hear, there's just no chance we'll ever probably see, talk to, or communicate in any meaningful way?
Yeah. Well, the question is, isn't it incredibly frustrating that we seem to be so far away from even the nearest neighbors that we're not going to actually visit? To begin with, maybe you don't have to visit. Maybe you were out of the room. I used the example of the Roman Empire. I get a lot of information from those guys, but I can't go visit them. And it took 2,000 years to get there. And you would have the same. I don't think that you would ever send. Why would you send the organisms? Maybe you could send some DNA. But even then, human DNA, it all fits on a CD. Why not just broadcast it? But you need an assembler at the other end. Right? Send them a Maker magazine. Who's having this? Transportation. Yeah. On the one hand, is FTL, fast light travel, actually impossible? One should never say impossible. But the physics that we know suggests that you're not going to do it. And maybe you all look at this the other way. that if it were possible to easily go from one star to the next, that maybe we wouldn't be here for other reasons. Maybe that somebody really would have colonized the entire galaxy, and nobody gets, it's a winner-take-all situation. And Microsoft of the galaxy, took it all. Okay, so maybe it might make an interesting short story. The reason that the distances are so far is that if they weren't, we wouldn't be here asking why are the distances so far. That's just a thought that occurred to me as you asked the question. But I don't see it happening, but I'm not a specialist in these kinds of physics. I asked a theoretical physicist who does worry about this stuff once what he thought about passing light gravity. He said, I doubt it, Seth. He said, because if it were possible, if you could do it, then, some guy would pop up in the chair next to you, and that wouldn't be nice. That was his answer. Listen, I want to keep you here forever. I'm not happy to answer the next question, but I do want to say was, yes, ma'am.
These red dwarfs, are they, the red dwarfs that you mentioned, are they only visible using infrared telescope, or, I'm wondering, would they be visible in ancient times? Like the first astronomers, would they observe these red dwarfs?
Yeah, red dwarfs, are they visible? Do you need infrared? No, you don't need infrared. They put out quite a bit of infrared, but the peak of their spectral distribution it's in the red, but it's in the visible red. So the thing is, with your naked eye, put some clothes on it quick, your naked eye, you cannot see any red dwarfs. None of them is at least 6th magnitude, which is kind of limited to the naked eye. However, if you have a pair of binoculars, you can see Barnard's star, which is like 6 light years away. And, you can see there it is, a little star. Might look a little bit reddish. There are a lot of them. They absolutely dominate the galaxy. Not only in numbers, but in terms of mass.
So where would you start?
Well, there are people who've studied these things. I mean, if you have telescopes, of course, you can find lots and lots of red dwarfs. So there's a guy at Georgia State, actually, Henry, and he's mapped out thousands of nearby red dwarfs and thinks he has most of the nearby red dwarfs. He just has a long list, and I would just go through that list. That's what I would do. I like red dwarfs.
You said at the beginning that a lot of the other Seti people are looking at different variations on life.
Are we looking at other variations on life forms? Actually, there are the other Seti people, the majority of the Seti people, they're like 50, 60 Seti researchers, okay, at the Institute. And all but, the number of people that are doing Seti, what I talk about here, is the number of people in the first row. So that's very small. And most of those are the engineers. So most of them are worried about life on Mars or some of these other places that we talked about. Some of them study meteors, stuff like that. So it's all connected with life, but they're looking for life that's probably going to be microbial. Yeah, there are a lot of them that have the kind of expertise that anybody who uses BioCurious has. So they're looking for using, data from NASA rovers, orbiters, various telescopes. Haven't found it either.
What sort of computing power are you using to analyze signals?
What sort of computing power? We have sort of special purpose hardware still, which is not good. You don't want to get into computer business. SETI traditionally has done that. That's not good. You just want to buy general purpose computers and just in software, you do what you need to do. And the more computing power you have, the better. But the real problem, the real bottleneck is actually not so much hardware. The Institute keeps buying hardware, getting into the hardware business. I think that's the wrong thing. The real bottleneck is just some money to pay people. You need some people. You still need people. Might as well use them before the end of the century. You won't need the people. Might as well do it now. So and I say, by the way, that is Kyle here? Kyle here?
Kyle Taylor?
Yeah.
No, he's not here now.
Okay. But Kyle came over to our institute a couple of weeks ago because we did a story about making glowing trees. We have a weekly science radio show. If you're interested in science, bigpicturescience.org. Big Picture Science. It's broadcasting over the air, but it's much faster just to get it on the web. Yeah, we did the interview with him. I think it ruined astronomy when all the trees are glowing, but they'll look neat.
You should have actually said we had a visitor from Bar-Ilan University in Tel Aviv, researcher named Ido Bachelet, who's a real friend to us here. And he is one of the guys kind of pioneering this idea of DNA origami. one of his, they keep coming up with what I call, in a good way, blog post science. They come up with these great little experiments that people go, oh, hey. So they came up with a DNA nano robot. It's all just full of DNA with RNA inside it. They said, oh, what would it take to accelerate this thing to about 1% the speed of light? Oh man, that's a mass spec. We can do that.
Yeah.
So let's go ahead and we'll send these things out, and any of these water worlds that may exist, we can see them with RNA world, and if there's not life there, then just wait around a few billion years.
It'll be the Johnny Appleseed is a Milky Way. Well, I mean, that idea is, I mean, Watson and Crick, one of the two of them wrote a paper on this. They thought that this is how we got where we are. We were seeded by the aliens, and deliberately so. Not just the way Mars could seed us by just having a rock kicked off Mars. That would work from Mars here. But if you're talking about another star, okay, now the rock is in space for maybe a couple of million years, and now the radiation environment probably really damages everything biological in that rock. Also desiccation and stuff like that. But he said, look, no, we'll put it in a thermos bottle, we'll protect it, we'll just fire it off like you're talking about essentially. And yeah, you wanted to do that if you have the need to see.
Let me, before we say bye, I just want to hold up. So Seth comes across so great in these talks, and it's nice to know he actually does the same good job in his book. So Confessions of an Alien Hunter. You guys actually still read books and not just blog posts.
Never heard of
That's a great thing to do. So would like to just thank you for coming here. Thank you so much.